welcome to lecture 53, risk-based maintenance 1, part 1. This is under module 11, prescriptive safety analytics 2. In this lecture, I will introduce different maintenance policies, inspection and maintenance strategies, risk-based maintenance approach, risk-based maintenance methodology, and then we will discuss a case study. So, the development is based on primarily our own work and as well as with available literature in the different sources. And also, as maintenance is an important issue, and maintenance is one of the risk control system, so it is very important for all of you. And second is that whatever the treatment what I will be doing today and tomorrow, means what I mean to say this class and next class. So these are to be considered as some guidelines or some way of handling these issues, not necessarily that this is the complete set of doing these kind of exercises, but obviously after going through this lecture you will have the understanding that how risk-based maintenance is performed. First, I will introduce what is the objective of risk-based maintenance. So, when we talk about maintenance, the primary purpose is that the equipment or the system that should work without any failure. And so long we are interested in the prevention of failure and we are not attaching the cost of failure, then it is basically reliability centered approach. But a failure may result into accidents or from the safety point of view, as well as what I mean to say that failure has certain cost and consequence. So if we consider both failure and the cost of failure or the consequence of failure together, then you are bringing the concept of risk. And if your maintenance is maintenance approach consider risk minimization as the primary objective, then that is risk-based maintenance. When you say that risk-based maintenance, essentially you are also considering the reliability part of it, because risk has two components, one is failure, another one is its consequence, where reliability consider only the failure. So risk-based maintenance is bigger set than reliability centered maintenance. Now when you go for risk-based maintenance, when you go for reliability centered maintenance, these are all decisions what you have to decide on the equipment what you are, or the system what you are going to maintain. If it is safety critical equipment, maybe obviously risk-based maintenance will be better approach, but if it is not that safety critical, but rather that it is a production critical and the safety consequences are less, then you will go for reliability centered maintenance. But anyhow, then what is the risk-based maintenance methodology? The risk-based maintenance methodology provides a tool for maintenance planning and decision making to reduce the probability of failure of equipment/system and consequence of the failure. So now I think risk-based maintenance and the approach or the methodology takes into account both the failure of the equipment and consequence of the failure, and then it is a planning tool. It is not that things have already happened. It is a planning tool planning tool means it helps in doing the correct maintenance so that the desired objectives will be satisfied. Now, if you go through the history of maintenance, then let me tell you that from 1940 to till date, we have just done the literature review, and till date means this paper I think we have published in around 2010 or 2013. So that means I can say that there is no much change probably in the maintenance in last 10 years. So if I consider that, then the 1940 to 2000 or 2010, the history is like this. The maintenance philosophies can be broadly classified into 4 generations. First generation, which basically 1940 to 50, where the approach or philosophy is fix it when broke, basic and routine maintenance, and corrective maintenance. The second generation, planned preventive maintenance, time-based maintenance, systems for planning and controlling work. So, preventive maintenance basically that means you don't want the failure to happen, but it is a certain plan you will do. Time-based maintenance is also that, okay, if you find out that what will be the interval of maintenance, and systems for planning and controlling work, that is also work related maintenance point of view. Third generation, the additional part is basically condition based maintenance. Okay. So maybe second generation, if we say time based maintenance, it may be based on the failure history that maintenance planning is done. But when we are talking about condition based maintenance, we are bringing the proactiveness into the maintenance philosophies, means we are not waiting or we are not deriving based on reactive data like failures, rather you are monitoring the health of the system or health of the machine or machine parts or equipment component, and as the machine require maintenance, then there will be signature change from a machine which doesn't require maintenance to a machine which requires maintenance, and then using this health data, health of the equipment system or component data, you will set the maintenance or you will do the maintenance accordingly. So that is condition. You know the condition of the equipment, system, machine, component, and do it. Then after that, computer aided maintenance management and information systems, so to make it data oriented. And then workforce multi-skilling, skilling and team working, that is related to the competency of the human. And obviously these are all proactive and strategic, means before failure occurs, so you maintain. In the fourth generation, the additional part is the risk-based maintenance, and risk-based inspection and risk-based maintenance is added, and risk-based life assessment, or I can say that life cycle assessment, and obviously reliability center maintenance, condition-based monitoring, computer aided maintenance, all those things, these are very useful and this continues. And in the process you will find that the total productive maintenance, the TPM is a big concept, so that also came into picture. So that means this is another philosophy. So this is the way from the literature what we got. So it is not exhaustive because it is based on our search. So there could be more. So but these are sufficiently broad, and you are getting some kind of that evolution in the maintenance philosophies. Today we are saying that risk-based inspection and maintenance, and now in fact because of the industry 4.0 technologies available, monitoring the condition and then doing the correct maintenance, and also considering the risk that from the failure and its consequence point of view. If you combine these things, definitely your maintenance effectiveness is going to increase. So then we talk to people who are in industries, and we just try to understand that what kind of maintenance they are doing, and that we are saying that inspection and maintenance strategies. First we ask about the, I listed down the inspection strategies, and next slide I will show you the maintenance strategies. So if it is a critical system, safety critical system, risk-based proactive inspection, and non-critical system also risk-based proactive inspections are being carried out. Safety walks, spot inspection, scheduled inspection as per organization SOP, inspection by organization as per regulation, audit by external agencies. These are the general inspection strategies what are being adopted in high risk industries, particularly in process industries. And then if you see that in the different type of inspections, what are the time duration? So it varies from risk-based proactive, varies from system to system, with most critical system having compulsory daily inspection. For non-critical system varies from system to system, with proactive organizations having daily or otherwise weekly inspections. Safety talks usually weekly. Spot inspections randomly held, time duration 2 days to 1 week, and schedule inspection as per organizations, that monthly or quarterly, and inspection by organization as per regulation 6 month or 1 year duration, audit fixed time based, maybe 1 year. So this is what actually we understood from people from the industry. So again I am telling you, as it is the collection from the industry, so it reflects what we could have collected. If there are something more, definitely you add on, because there are many participants who are from industry. You can also write down in the discussion forum that these are the other maintenance inspection strategies being followed. Similarly, maintenance strategies, if you see that risk-based proactive maintenance depend on outcome of daily inspection, that is the time duration, that when you will, at what frequency or what interval you will do, that depends on the outcome of the inspection. Then risk-based proactive maintenance, non-critical systems, it is usually weekly. Then scheduled maintenance as per organization SOP, it is usually monthly. Maintenance by organization as per regulations, 1 to 2 years duration. Maintenance as per manufacturer standards, 2 to 5 years, depend on the equipment. And corrective maintenance, random, depends on the unit failure. Obviously, corrective maintenance, failure takes place, you have to maintain it. So these are the some strategies. Now, which strategy is good, which strategy is bad, and these are the safety risk decisions, these maintenance decisions. Now, it all depends on the many things, the equipment, the importance of the equipment, the criticality of failure, safety consideration, then your budget, so many issues are involved. Then we will discuss the concept of risk-based maintenance, and that how the things will be done. When we say risk-based maintenance, obviously you can understand that risk assessment is one of the important part of it, and risk assessment point of view, we have given you enough information about risk assessment. By this time, you are quite highly knowledgeable person in the risk assessment point of view, and then the maintenance planning based on risk, that is what you may be interested to look into from this lecture. Whatever may be the things, so there are two main phases, as I told you, that two main phases. So one is risk assessment and maintenance planning. And when I say maintenance, so wherever needed, inspection and maintenance can be considered. So it's a general term. Sometimes we are using as inspection and maintenance, sometimes only maintenance. So more or less interchangeably I am using. Sometimes maybe only maintenance, sometimes inspection maintenance are important. So in the risk-based maintenance, the maintenance, inspection and maintenance activities are prioritized based on quantified risk. That is interesting part of it. And high risk components are inspected and maintained usually with greater frequency and thoroughness. Suppose you think of a system, so entire system there are many equipment, and again against each of the equipment there are many components. So now it is not that you will maintain all of them together with same rigor and thoroughness. Based on risk you will prioritize. So that is the important part of it. Now if you want to say that what are the different basically modules under risk based maintenance, we say 6 module. First is hazard analysis, then you find out the likelihood assessment, consequence assessment, risk estimation, risk acceptance, maintenance planning. These all the things you have gone through. It is not that you don't know what is hazard analysis or you don't know what is likelihood or probability of failure. Everything you know. So risk acceptance also I have discussed. We said that risk acceptance means based on certain standard, maybe for your organization or maybe international or national standard, whatever being practiced, so that you follow, and if it is accepted, fine, you continue with the maintenance. If the maintenance is the reason for the failure, it is not that when you talk about the failure of a equipment or when you talk about consequence of the failure, all the time that it may not be the maintenance or inspection is the issue, but whatever may be the things, when you are talking about the hazard analysis, identification, risk assessment, and then finally we are talking about how to improve the performance of the system or component. So one way or other way there may inspection and maintenance play a significant role. So that sense we are basically talking about. For a particular equipment, if the expected computed risk is below the acceptable level, we do not require to do anything, we accept this. Or if you think that no, the risk is higher, but you cannot reduce it further because this inspection and maintenance will not contribute to the reduction. In that case, from risk assessment, risk based maintenance point of view, you have to accept the risk, you have to go for some other risk control systems. So then final part, once risk is known, and then final part is maintenance planning. So let us see that what are the how you will do the risk based maintenance. Here we are talking about risk based maintenance from the plant or the system as a whole, which is definitely little bigger than equipment. So what we are saying that as a manager of the maintenance chief or maintenance manager, so what you can do, you divide the system into manageable units. Then consider one unit and do all the steps, what 6 steps I said. First hazard analysis, likelihood estimation, consequence estimation, then evaluate the risk, and then identify high, medium, low risk units. That means you are basically categorizing the unit in terms of its risk. So if it is high, medium or low, whatever that way, that kind of classification you do. After that you find that is the risk acceptable. If the risk acceptable, if it is yes, then you go for the second unit, proceed and the same way. But if it is no, so then what is required? And if you think that maintenance will improve the risk, means will help in reducing the risk, then go for maintenance and do it. And this is the general approach for risk based maintenance. Okay. And you will continue so long your that all the units are not considered or their risk based maintenance schedule is not fixed. With this background, I will just give you one case here. This is basically that blast furnace gas utility system, and here you see ultimately the blast furnace, this is one subsystem, which is producing blast furnace gas. Suppose the gas goes through dust catcher, then there is wet scrubber, mist eliminator. So I can say this is basically gas cleaning, holding and cleaning system. And then the BF gas going through turbine. This is gas expansion turbine. So, and then this, what is happening, that gas expansion turbine that expand the gas, and finally the utility equipments, they are basically using this, and you can generate electricity. You can also use this gas for some equipment, utility equipment functioning point of view, that may be burned and give fuel to the equipment whatever is needed. Okay. So here this is what is explained here, that okay, this is our system. Now you want to adopt risk-based maintenance. Okay, how can you do it? So if you go by the approach what we have discussed so far, we said that first divide the systems into manageable units, and then consider each system one at a time, and then you continue doing it. Now, for the demonstration point of view, we have not considered the entire system, rather we have considered only the gas expansion turbine subsystem, and then for the turbine, for the case where we did the that study, it is in a plant, basically we have done it. It is also our own work. One of my MTech students in Ananda, he has done long back. And then actually what happened, we first find out that the turbine subsystem, what are the components for the turbine, what we have studied. So then we found out that rotor, stator, guide wage, blades, bearings, castings, diaphragm, governing system and valves. So these are the units. Now if you ask me how we have divided the entire system subsystem into different units, we have taken the help from the people basically who are basically knowledgeable in the plant. Okay, so that sense basically we have done that sense. Now what I mean to say here, that the failure scenarios for each of the unit just also identified. As you know that for every unit you have to understand what are the different ways it can fail, and then you have to find out the probability of failure, and if it fails what are the consequences. So these are the risk assessment stages or steps you have to continue, and once you perform all those things, then only you will be able to understand what is the risk of rotor for all the unit risk you will be able to get. Here some of the scenarios we have mentioned. One, you see that rotor bowing due to overspeed, damage of rotor, damage of guideways, like this. Some of the failure scenarios are given to you, and these are the failure scenarios what the plant personnel, who are primarily the maintenance personnel, they said that these are the important one. So as a result, we are heavily dependent on them, and you can understand that if we think from the ideal demonstration point of view, there could be more failure scenarios, but okay, that is fine. But at the same time, this is also good in the sense it will help us to understand how the risk-based maintenance can be executed. So that means what I mean to say? I mean to say that for each and every unit, you have to understand that what are the failure scenarios. Here failure means in the fault tree diagram, the top event. For each of the unit, there could be more than one top event. So find out the top events, and if you can develop fault tree of this top event, and find out the basic events, and then from you get the data for the basic events, and then find out the failure probability of the basic events, and then finally find out the top event failure probability. So that means essentially what I want to say, you can use fault tree analysis. You can use fault tree analysis everywhere for all those things. And we have done fault tree analysis. Wherever required, we have done the fault tree analysis. So, I am not discussing the fault tree because already we have discussed such things. Then, using the that fault tree, as well as some cases where fault tree was not required, maybe historical data, so or the data given by the plant personnel, we finally found out the risk estimation for each of the things. For different units, then we found out the probability of failure in 1 year, and then these are the probabilities, and you see, if you compare the probability of failure, the governing system which is having the maximum probability of failure, and it is quite large value also. Then for the consequence part, what we have done, we have taken the help from the paper given by Khan and Adarer 2003. When we studied this system, that time this paper we got and we use it. Now over time there are many more that loss factors are included in the model, so we can use them. So then the consequence calculation will be different, but nevertheless, so this is one of the important way of finding out the consequence. It is very difficult to get consequence. So now 0.25 a square, 0.25 b square, 0.25 c square plus 0.25 d square, where A is the system performance loss, financial loss, human health loss, environment loss. So major broad categories of loss because of failures we have considered. And then also we found that in Khan and Adarer paper, so how to quantify the system performance point of view, loss factor. So he has given these 5 different criteria, very important to optional, and what could be the performance that factors that these values are taken into consideration. So now using these, the consequence, whatever information what we are showing you here, using this we found out that the consequence of the unit, different unit like this. Obviously, if I consider consequence point of view, now valve become maximum, but this governing system, this is lower than the other, but at the you may question here that why this is lower, it is not correct or wrong, but please understand, we have done it based on the available information, based on the available literature, as well as talking to the people there at the time of the study. So what I mean to say here then, that means you have done this, that failure probability you have identified, and then you identified or quantified the loss or consequence, and also you have computed the risk. Once you know the consequence as well as failure, just 2 parameters, risk equal to P cross C, this 2 parameter, if you multiply, you are getting this, and you will see that this value is very high. Which one? Governing system risk value is high. This is primarily because of the probability of failure is very, very high. Okay. So now decision is which system you will consider. If you go by risk, obviously the governing system you have to consider first from the risk reduction point of view, and on the other hand, from the probability failure point of view, this is the maximum because the governing system probability of failure is quite high, higher in comparison to other systems. So even if you go by that failure based or reliability based, so that means you will choose this one. It is whether good or bad, but this ultimately in the both approach, the governing system should be considered first. Now what we are basically trying to tell you, so we know that governing system, other units we are not going to show you, I will just show you with only governing system. So then how you will proceed also further? Further, you got the risk value, but you have to understand whether the risk can be accepted or not. Now, for risk acceptance point of view, we are following ALARP principle given by Melchers 2001. What it is said that if the risk value is 10 to the minus 3 per year, this is more than this, so this is unacceptable, but if it is less than this, it is acceptable, but again there are certain categories, like if it is 10 to the power minus 5 to 10 to the power minus 3, this is known as ALARP region, risk must be reduced if reasonably practicable. And then if it is 10 to the minus 6 to 10 to the power minus 5 per year, then it is acceptable risk, and if it is 10 to the minus 7 to 10 to the power minus 6, this is basically negligible risk. So, Melcher has given this, that negligible risk, acceptable, ALARP region, and obviously this is unacceptable. So, okay. So, now with using this ALARP, that risk values given by Melcher 2001, we have basically created or basically followed, I should not say we have created, this is the approach we followed, that we first found out the risk index for each of the units. What is risk index? What is the actual value of risk that you got, and what is the acceptable risk value based on certain criteria. Now, if the unit whose risk index exceeds 1, that should be considered. Okay. So, you consider unit. So, accordingly, we have done it. What we have done? We consider 10 to the power minus 3 per year is acceptable, and then we basically actual risk versus this. Suppose 6 into the power minus 6 by 10 to the power minus 3. Just you see that actual value and acceptable value. Then fine. So, what is the value we consider? Let me consider that acceptable risk 10 to the power minus 3, 10 to the power minus 5, 10 to the power minus 3. Now, see this one, this value, if you divide by 10 to the power minus 3, then it is 135, because that 10 to the power 2 will be multiplied, 100 will be multiplied, this one. Now, if this one is multiplied by 10 to the power minus 3, so 6 into 10 to the power minus 3, so 006. Okay, so that you have to then okay, sorry, I got the point now, that here we made a decision. What is the decision? That not that for all the unit we consider the acceptable risk value 10 to the power minus 3. For example, for rotor we consider 10 to the power minus 5, because 6 10 to the power minus 5 actual value 6 into the minus 6 by 10 to the power minus 5, that means 6 into the minus 1, that is 0.6. So, for this one also acceptable value considered is that 10 to the power minus 5, and for this one again 10 to the power minus 5, and for this also 10 to the power minus 5, for this 10 to the power minus 5, for this 10 to the power minus 5. That means we are saying that risk much lower risk value, we said the acceptable risk for these other units. For valve governing system, also for valve we have considered 10 to the power minus 5, 10 to the power minus 5, then it will be 7. If it is 10 to the power minus 5, this will be let it be 7. Okay. Now, for the governing system, we have taken little higher value as acceptable value, because its risk value is very high, and if you take much lower value, it will not be possible for you to reduce to that level, because considering the acceptable risk is a much lower value, always desirable, but you have to understand that whether you are able to reduce it to that level based on certain risk measures. So, if it is not possible, so you should not be unnecessarily more optimistic. You have to be very, very careful when you are talking about what is the acceptable risk. As per this criteria, so for governing system we basically talk about within LRP level, just below the unacceptable level 10 to the minus 3 that which is considered starting point. This is some kind of that stepwise improvement you are talking about. Now your risk value is 1.35 10 to the minus 1. So you want to reduce it to 10 to the minus 3. If you achieve this, next time again you target 10 to the minus 5. So that is the way it should be done. So from here you can understand that our system to be considered is governing system. Now let us see that how we are doing it. Then what we have done, we thought that okay, if you want to improve the risk, means reduce the risk of the governing system, then you have to understand that what are the components that basically contributing to the risk of the governing system. That means you further break down the governing system, and then we have done this, and finally based on the inputs from the plant, then we found out that oil cooler, oil filter and servo motor, these are the three components in the governing system. They are basically contributing the maximum to the failure of the governing system in comparison to other components. And we have chosen that okay, forget we consider that other component failure probability is negligible, and then with reference to this fault tree, so this fault tree, if we say that there are three basic events and the governing system failure related with OR gate, so this we prepared, and this is we are saying fault tree. In fact, I have not discussed here that we have created fault tree for other units also. Now you see that your risk value probability failure value is 0.27. If you want to, and your risk value is 135. Now what actually we have decided, then we decided that after talking with the plant personnel and considering the cost of maintenance, the acceptable risk for the governing system is 10 to the power minus 3 per year, and others 10 to the power minus 5. Actually I told you earlier that we consider 10 to the minus 5 here. Now if we want that the risk will be 10 to the power minus 3, sorry, this is the risk, yes, risk will be 10 to the power minus 3, and then we found out the consequence is 0.5. So then the probability that what is acceptable is 2 into the power minus 3. So from here to here. Now this is the actual one, existing one, existing. Now you want to reduce 0.27 to 2 into the power minus 3. So how can you do it? Here we are saying this is possible with maintenance. So what maintenance planning, or what will be the maintenance schedule? What will be the maintenance schedule? How you will plan for this and execute this so that this will reduce to this much? Here a lot of assumptions we have made. We thought that only maintenance can reduce it. If maintenance with other things you will do, obviously the reduction will be easier. So okay, for the timing assumption is yes, it is possible. Then what you have at your hand? You have the top event probability. Top event probability you have. You require to know what could be the basic event probabilities. So here in the left hand side you developed a fault tree, right hand side you just see the arrow, we are talking about you require to develop a reverse fault tree. What is reverse fault tree? That means I know the top event probability and the fault tree construction I have made. Now from the top event probability, how can we get the basic event probabilities? It's easy to tell but difficult to do. So maybe we can do iterative simulations, and that we can do. So you just think that yes, some kind of simulation is done, and then ultimately you come to the conclusion that your individual probability that oil cooler, oil filter, servo motor probability, failure probability should be this much. So 0.0365, it should be reduced to 3.15 into 10 to the power minus 4. 0.202 should be 9.43 10 to the power minus 4. 0.048 6.48 10 to the power minus 4. So actual value this, now you have to reduce to this level, and we are saying if you can do proper maintenance scheduling, and then it is possible. But again, let me tell you, this is grossly basically it's a huge assumption. Okay, so may not be that only maintenance will be able to do it. In that case, you have to not only maintenance, you find out other risk reduction measures, that all things you consider. But ultimately what we want that our probability values should be this, then only you will be able to achieve this. Considering that yes, maintenance is the possible, that, and then what we found out that the what maintenance you are doing, what the schedule you are doing today, now it has been, it needs to be improved too much. So oil coolers, that 132 days, within 132 days, oil filters schedule is 73 days, and servo motor 145 days. Assuming that maintenance will reduce, so now it is basically 0.0364, and now this is the failure probability, and maybe you are maintaining maybe some kind of that manufacturer data, that maybe once in 5 years or 3 to 5 years, but it is not possible. Now you have to reduce the maintenance schedule, you have to do much frequent maintenance of these components. Again, let me tell you, let me put the caution to all of you that this is a theoretical exercise. Obviously, we have taken the information from the real plant. We talked to the plant personnel, and they have verified the results, and they are satisfied. But I don't know whether this kind of reduction possible or not, or this main type of maintenance reducing the schedule is possible or not, and after that whether it was executed and finally the results were obtained or not, those information we don't have. So, but nevertheless, what actually this study is giving you, this study is giving you a indication, a guideline, a clear guideline that okay, how can you do the risk-based maintenance. Now see, it can be improved further with the use of maybe better quantification, maybe with the collection of data, more data. So obviously the improvement is possible, but the approach or methodology what we have proposed here, or we are basically showing to you here, this is sufficient for all of you. So with this, I conclude that this is another important lectures from prescriptive safety and risk analytics point of view, where we are basically talking about one of the key risk control system, that is maintenance. Some previous lectures I talked about many time inspection and maintenance, leading and lagging indicators of maintenance, but here we basically talked from the failure point of view, because we don't have that much of data how the linking with leading to this kind of database is not yet known to us. Now for every industry, for every plant, that kind of database generation is very, very important, and then these concepts will give you very improved results. Condition based maintenance is highly practiced and fine, but sometimes what will happen, this kind of data driven assessment along with the data, condition based maintenance data, because you cannot go for all equipment condition based maintenance. And again, at the same time, you have to understand that what is the contribution of maintenance in terms of reduction of probability of failure. So those things you have to understand. Here I have taken the help of two of my earlier work, one published in Journal of Hazardous Material and another published in Journal of Risk Assessment and Management. And based on these two publications, I prepared this lecture. Thank you very much for your patience and kind listening to my lecture. Hope it is useful to all of you. Thank you.